Hello students. In this video we're going to look at our first section of sampling in our last unit of this course. So let's go to our screen. Let's use the example of a population, IQ for example. IQ in the general population has an average of 100 and a standard deviation of 15. In our last section we talked about calculating a probability that a random individual selected from this population has an IQ greater than a certain value. Let's make that 115 just for ease of our calculations. So what's the probability of randomly selecting an individual with an IQ greater than 115? We can calculate the Z value. The Z value is going to be equal to 1. The area that corresponds to that Z value is 0.3413. Our answer, our probability that someone is greater than that, is going to be that value subtracted from 0.5, so 1587. Just under 16% chance of randomly selecting an individual from the general population with an IQ greater than 115. What we move on to in this section is sampling. So we take a sample of 100 people. What's the probability that that sample has an IQ greater than a certain value? A couple things we need to understand when we take samples is the sampling distribution of various sample means. We're going to use Excel to help us understand how we can look at this, because Excel is really great at creating samples. What we're going to do is go into data analysis, this random number generation, and we're going to use normal distribution with an IQ with a mean of 100 representing the average IQ in the population and a standard deviation of 15. What we want to do is randomly selecting 100 people from the general population. What would the average of that sample be, and what would be some other characteristics of that sample? So we have Excel do this. Shouldn't take very long. We're going to hide some decimal places in there. I'm going to hide the middle 90 or so values. So all the other values are there. We could calculate the average of that sample. And look at that average. It is 100. 100.5. Now, what would happen if we did another sample of 100 people in this general population? Would we get that same sample average here? Would we still get 100.5, or could we get a value of 113 or 87, or where will those the sample averages fall within? So let's go back here. Let's create our data analysis. What we're going to do is look at same type of situation. The average IQ from the general population is 100. Standard deviation is 15. We're going to do some crazy stuff here in Excel. We're going to have 100 different samples of 100 items each. So it would be like if you were to go and survey 100 random people in the population, ask what their IQ is, get that information, and then do that 99 more times to a different sample within that population. So Excel will quickly generate some numbers based on our parameters, and there they are. In the right situation, this could be a really good party trick. So just keep that in mind next time you're at a party and things are going a little slow. So we're going to hide these middle values, and we're going to hide the middle 90 or so, and we're going to calculate the average. Oops, not the sum. The average of that population is 100. We're going to increase decimal places for that. 99.9. If we do it for the second one, we get 97.5. If we do it for these other ones, we get those values in there. What is not showing are the other 95 samples. But what we can do with Excel is find the maximum average, maximum sample mean, which was 103.5, and we can find the minimum one. And we'll see that they're really close to 100. The population average is 100. We took 100 different samples. We found that the average, or the typical ones, are right around 100. The max is 103. The minimum is 96. What we also could do is take the average of all the sample means. So it's like an average of all the averages. And the average of all the averages is 100.1. Then we could also take the standard deviation of all the sample averages. We're not taking a standard deviation of the actual data within the samples. We're going to take the standard deviation of these values here. Standard deviation of all these values equals 1.35. Now if we were to do this again, we're going to get different results here. Each sample is different. This is random number generation, so these values are going to be different. If we were to do this process with, instead of 100 by 100, 500 by 500, our values will be different, because these values here depend on the sample size. So sample size becomes very important in this section. So let's take a look at what this means. There is a certain sample distribution of let's erase that. There is a certain sample distribution of the sample means. So let's write that in here. Distribution of the sample means. The average of all the sample means, that's the first thing we need to note. Average of the sample means will equal this population average. Now in our example it's really close, but if we were to do this again, or perhaps a bigger sample or more samples, this average here will become much more closer to the population mean of 100. So the second thing we need to note here is the standard deviation. Standard deviation of the sample means is equal to, there is a relationship between the population standard deviation and the sample size, or the standard deviation of the sample means and the sample size. The standard deviation of the sample means is equal to the population standard deviation divided by the square root of n. So we have to differentiate between the population standard deviation, this value here, and the standard deviation of the sample means. This better referred to as, or more easily referred to as, the standard error. Standard error, also known as the standard deviation of the sample means. So now that we know that the relationship between the standard deviation of the population and the standard error of the sample means is based on sample size, we can then look at calculating probability of certain events occurring based on the sample size. So let's take a look at, let's go back here. Let's take a look at an example question here. Okay, the example we're going to look at is in this document. This is from the course package. Suppose a distribution of monthly phone bills is normal with a mean of 80 and a standard deviation of 9. What's the probability that a sample of 36 phone bills will yield an average of $78 or less? So the key difference in these questions, based on questions we've done previously in this last chapter, is that it talks about a sample size, sample of 36 items. What we know is that it has a normal distribution of 80, and we want to know the probability that it is $78 or less. So there's 78. We want to know all of that area there. We know that the sample size is 36. The population standard deviation is 9. One of the first things you'll have to calculate is the standard error. Standard error uses that combined symbol, the standard deviations of the sample mean. You just remember that the name is a standard deviation of the sample means, aka standard error, which is population standard deviation divided by the square root of our sample size. So this works out to be 1.5. We go ahead and calculate Z just like we would normally. The difference is we have a sample mean of 80, or sample mean of 78, minus population mean of 80, divided by the standard error. We're going to divide by 1.5, not by 9. The probability and the distribution is now dependent on the sample size. So here we get a value, a Z value of negative 1.33. That corresponds to an area value of, let's write this down, area would be 0.4082, which then gives us an answer. We're going to take that value, subtract it from 0.5, we're going to get a value of 0.0918. So there's a 9.18% chance that a sample of 36 telephone bills is going to have a value of $78 or less. Second part of this question, right in there, is we want to find the smallest interval that contains 95% of the sample means. So we're going to erase this. We're going to draw out population, or the normal distribution, as an average of 80. What we want to know is the interval that contains 95%. So this value in here, 95%. 95% of all the sample means is going to be between these x values. First thing we want to do with this question is find the area that corresponds, or find the Z value that corresponds to a certain area. 95% is all within that area there. It's an interval, so it's half, it's just split evenly on both sides of the mean. So the area in this section would be 0.475. Area on this section would be the same. The Z value that corresponds to that area of 0.475 is 1.96. So now we have our Z formula. The only thing we don't know is the X sample mean, is the X bar value. So 1.96 is going to equal the sample mean minus population mean divided by our standard error of 1.5. This sample mean, the upper limit becomes a value of 82.94. On this side, if we were to do the same thing, keeping in mind that on the left side it's going to be a negative Z value. This sample mean becomes a value of about 77.06. So what this means is that if we were to do this sample, sample the 36 phone bills, if we were to do this 100 times, we should expect to find 95 of them between this value, lower limit, $77, all the way up to about $83. 95% of the sample means should be within that range. 5% of them would be outside that range.